Hello, everyone, and welcome to the Frameworks Base workshop, Building Frames on Base with OnchainKit. Joining us today is Taylor Caldwell, who will be taking us through this session. And with that, I'll pass it over to Taylor to get the session started.
Awesome, thank you. Hey everyone, I'm Taylor from the Base team. And today I'm going to be talking about how to build frames on Base using OnchainKit. So here's a quick overview on what I'm going to be talking about today. So firstly, I'm going to be giving a high-level primer on what frames are, just in case anyone in the audience isn't familiar. And then from there, once everyone has the primer on what frames are, I want to introduce a toolkit known as OnchainKit that provides utilities for developers for building on-chain applications, including frames. And then from there, once we have a good understanding of frames and OnchainKit, I'd like to put the two together and teach you guys how to actually build a frame on chain on Base. So without further ado, let's start here. What are frames? So frames are a way that anyone can turn their social posts on Farcaster or casts into a fully interactive app. Here we see a post from the Coinbase handle that made a post about a frame that allows their followers to vote on which box should or what ad to put on a box for an advertisement. So here you can see that it's not just a regular post, but instead it also provides an image and a couple buttons down below that allow the users to actually vote and cast a vote on which box to mint. So the way all this is possible is that the Farcaster team actually extended an open standard or an existing standard known as Open Graph. If you think way back in the day when you first post a link on social media, when you post a link, it was kind of just a link. Eventually, the Open Graph standard came out and allowed that link to not just be displayed as a link, but to instead be displayed as a rich set of data of like static data. So you have a static image, and then you also have a static description at the bottom of your post. So if you go to like a place like Twitter today, you'll see that if anyone posts a link, you'll see an image preview of the link that they post and a description on what that link is about or what the website is about. So the Farcaster team took this standard and extended it for Farcaster to allow not just static data to be displayed, but also rich dynamic data, such as buttons and dynamic images that can be updated upon button click. So the way this works under the hood, so if we take a look at the Coinbase post that I showed before, you'll see that on the left is the metadata or the Open Graph metadata and Farcaster data for frames that is used to actually display the frame. And then on the Farcaster client, that gets translated into what's known as a frame today, where you see the buttons and the image. So when we talk about frames today, it's the use case for social media is pretty obvious. You can get a lot of access to a lot of data for your applications. So things like a user's social graph, who they follow, and you can drive a lot of engagement with your posts. So the value prop for social media is definitely there. One question that comes up when it comes to on-chain development is why should we care about frames and bringing them on-chain or adding any on-chain aspects to a frame? And to dig into that a little bit, I want to talk about Base's mission. So for the Base team itself, we've had a mission of driving or building a global on-chain economy that increases innovation, creativity, and freedom for everyone. And the way we plan to do this is to drive over 1 million builders on-chain and bring 1 billion users on-chain as well. So we've seen this over the years, and we've actually been striving towards this for the past year or so. We've seen on-chain users continue to grow. We've also seen on-chain transactions continue to grow. And all of this is driven by people building on-chain apps. Most of those apps today are standalone dApps, but what really unlocked these dApps to strive today is the on-chain capabilities, the decentralized capabilities, and the tech that has come out in the past few years. So you can think of everything from being able to launch your own ERC20 token, your own ERC721 NFTs, just the blockchain itself. All of these new pieces of tech kind of created new use cases that could be built and drive this economy that we see up on the screen today. And we think that with introduction of new tech like frames and new opportunities with frames, we think that we can further drive use cases and help continue those use cases to grow from a social media perspective. So with that said, let's talk about how we can actually build a frame and bring it on-chain. So I want to introduce OnchainKit. So OnchainKit is a set of, or a toolkit that is composed of React components and TypeScript utilities for building on-chain applications. So this is a toolkit that's built in-house at Coinbase by a team. It's fully open source. And the goal of it is to help developers build and superpower their on-chain applications. And this also includes applications like frames as well. So if you follow the QR code link here, it'll link you to the OnchainKit developer docs. And then, and then once you visit the docs, you'll also see a link to get started quickly using a Bootstrap project known as a frame in 100 lines. So this is really a way that you can get started building a frame if you're participating in the hackathon this weekend, to just get started building a frame and have it up and running within like 5 minutes in simple 5 steps. So you can see it here. So you can actually just clone the project. And then if you want to do any customization to the boilerplate, you can do that. So we have the option to modify buttons, images, and then it's very easy to deploy. So if you actually fork the repo, you can deploy it straight to Versal, and then you can actually test it on either Warpcast embed tool, or you can cast it directly to Farcaster and test in production if you'd like. OnchainKit also provides a local debugger for local debugging that I'll introduce later on in the slides. So if you do run this project, this is kind of the initial like root file that you'll see. It's no different than a traditional web page. So you'll see that it just renders some placeholder data. And then at the very top, you'll see that we're defining some metadata for Open Graph. So this is the same Open Graph data that you'll see on traditional web apps. The only difference is if you see here on this line, we're passing in frame metadata that I've obfuscated at the top. And the way this frame metadata gets defined is we use OnchainKit's get frame metadata utility method to actually define the metadata that we want to display in the frame. So here you'll see that we're importing get frame metadata from OnchainKit at the top of the file, and then we define it here. And then as we go through, we can actually define how we want to compose our frame. So here we're adding 2 different buttons. One button is a button that says story time, and another button is a button that says send base Apolia. That makes a transaction. Additionally, we can add an image and define any aspect ratio. And if we also want to provide an input box, we can do that as well. One thing to note is that the way that buttons and frames actually respond, or the way you respond to a user's interaction with a button on the frame, is that each button click will trigger a handler that points to a post URL that links to your backend API, or a backend API that you define. So that's what this post URL field is here for. So for example, if you click the first button that says story time, that will trigger a request to the URL that's defined here in this post URL field. And that'll be the handler for every user interaction. This is what the API route looks like for handling user interactions. So if a user does click on a button, it'll trigger this handler. And then in OnchainKit, we have the concept of, or in Farcaster Frames, we have the concept of signed and unsigned messages. So the first thing you'll want to do when a user or you're handling a user request is that you'll want to verify the message that you receive on the backend. And this is just to ensure that the request isn't spoofed or anything like that, and that is a valid message. So that's what this line is doing here. We're using OnchainKit's get frame message method to actually validate any incoming messages to our backend. If a message isn't valid, we just simply return and throw an error. And yeah, this is pretty much best practice for any request coming into your backend. So you'll just want to continue to verify any messages and throw errors if a message isn't valid. From there, before you send back a response, you can perform any logic that you like. Here we'll see examples of us parsing the actual incoming requests and data associated with the requests. So the first highlighted line here, we see that we're parsing the message input from the input box of the frame. So if a user typed in any message into the input box, we can parse it here in the code and do whatever we'd like with that. On the next highlighted line, we actually are trying to access the state of the message. So Farcaster Frames allow you to store state across different frames. So that's what's happening here is we're reading message.state. We're getting that state that's stored in the frame request, and then we're actually storing it in the state variable. And then from there, we can do stuff with it, update it if we need to. In the next highlighted line, we are also, this is an example of accessing or reading what button was clicked from the user. So here we'll see that we're checking if the button was the third button in the frame that was clicked. And if so, we're returning a redirect response and redirecting the user to a specific URL. So once you receive a request from the user and you have your custom logic that you want in place, the next part of the flow is to send back an updated frame to be displayed to the user. So that's what this code snippet represents. So here you'll see that it's very similar to how we initially defined our initial frame. The only difference here is that we're using get frame HTML response, the get HTML response method from OnchainKit rather than get frame metadata. But other than that, providing the same type of data. So here we're defining 3 more buttons in a new frame. Similarly, we're providing an updated image. And then also similarly, we are defining a router or an API endpoint that we can use to handle any button interactions on this new updated frame. One last thing to mention with OnchainKit is that it does have a local frame debugger. So if you go through and you're developing your frame using OnchainKit and you don't want to deploy to production, you can use what's known as FrameGear, which is a local frame debugger that comes packaged with OnchainKit. So you can run this locally and then separately run your frame. And then if you actually take the localhost URL of your frame and paste it in and fetch the data, you'll be able to display and see your frame in FrameGear itself. The functionality of FrameGear in this debugger allows you to simulate any interactions with your frame to make sure that it's working correctly. And then on the right-hand side, you can actually see a list of frame validations. And what it's doing there is it's validating that the metadata that defines your frame in the web page is actually valid and syntactically correct. So that's kind of a high-level overview of the flow of different frames or the flow of frames itself in frame development. So if you saw before, we initially defined our frame for our web page. We defined a backend where we'll handle any user requests. And then once we receive a user request, we basically send back an updated frame to the user. And then the interaction continues from there. So with that said, when it comes to building frames on Base, there's 2 parts of the Farcaster spec that are natively on-chain or have to do with on-chain interactions. And I kind of want to point those out in this section. So this slide show we see 3 three different examples of on-chain frames that have been developed before. So the first one is the frame I showed you before, which is a voting interaction where users can vote on a specific ad that will be displayed on a box, and they mint an NFT for it. The middle frame is an example of an on-chain frame, or an on-chain e-commerce frame that allows you to buy a hoodie on-chain, and you'll actually get a physical hoodie and mint NFT for that hoodie as well. And then lastly, there's a recent drop that was done by Xcopy, the artist, that is a great demonstration of the two different interactions for on-chain interactions built into the Farcaster spec. So I'll use that as our example today. So here we have the Xcopy Farcaster frame that allows you to mint an NFT. It allows you to mint in two different ways is powered by the Farcaster spec. So the first way is very simple and is built into the spec itself. It's called the mint action. So the way you can do this is that you create a button with an action with the value of mint. And what this does, it creates a mint button for the user and allows them to mint an NFT using warps on Farcaster or Warpcast. And really the only setup that you have to do with this is you define a button with an action of mint. You can provide a custom label. Here we just say the string mint. And then for the target fields, we define what's known as a CAIP10 formatted string. And what that means is that it's a formatted string that's delimited by these colons. And the format is basically chain ID. And here we can see that the chain ID is 8453. That points to, or that is the chain ID for base. And then we also define the smart contract for the NFT itself, which is that long hexadecimal string that you see. And then at the very end, you'll see a 1 after a colon, which is for the token ID of the NFT to mint. And that field is optional. It's just if you have multiple NFTs, you can mint specific token IDs. So all in all, here we're defining a mint button that it points to a specific contract on Base to mint a token with the token ID of 1. So what happens here is that when a user clicks the mint button, in the client itself, in Warpcast, they'll see this modal pop up where they can actually mint the NFT using warps, or it'll link out to the actual site itself. This is a modal for like a manifold mint, so it links to manifold. So yeah, that's a pretty simple setup if you're interested in NFT mints. Another way to accomplish this, a very similar flow, is using the transaction action for a button. So here we have a button that we're defining with the action of TX, which stands for transaction. And we provide it with a label of mint with wallet. And when you define a button with an action of transaction, you actually have to define two different URLs. The first URL is a target URL, which is very similar to the post URL that we showed before, where you're responding to the user's interaction. And what that looks like is this snippet here. So as you can see, it's very similar. At the very beginning, we're validating the user's request and message, seeing that the message is valid. And then the unique part is down here where we're actually defining data for the transaction itself. So here we're going to set up a transaction to be performed at a later point. Here specifically, we're encoding some function data and including the smart contracts ABI and also the function that we want to call. Here we're going to call the function on the contract, or the mint function on the contract. And then we pass that data into this frame transaction response type, where we define the chain ID again of base, so 8453, and then also defining the method we want to perform, which is just going to be the traditional ETH send transaction method. And then from there, this transaction will get packaged up, and then our endpoint will respond with that transaction data. From there, what happens is that Warpcast or the Farcaster client will take that transaction data responded from our backend, and it'll actually display a modal to the user with an opportunity to connect their wallet to execute the transaction. If the user does continue and continue with their wallet and connects their wallet, they'll be able to execute and confirm the transaction to be performed. If they do and the transaction goes through, that's when the next URL that's posted here or defined here will be called. So this is a transaction callback endpoint. And what happens there is that the request will actually have the transaction hash of the transaction that took place. And then from there, you can perform any other action depending on if it succeeds or fails. So those are two different ways to perform on-chain actions using the Farcaster spec. One is a built-in mint functionality that allows you to mint right off the bat directly in the Farcaster client. And the other one is a more customizable, more powerful utility that allows you to perform any transaction on-chain. This could be minting, as we demonstrate here, or it could be any other function call in the smart contract. So that's pretty much a high-level overview of the different topics I wanted to cover. So first we went over and I talked about, or gave a little introduction on like what frames are, talked about why they're important to on-chain development, and important for Base as an opportunity for builders to build on. After that, I talked about OnchainKit and gave a brief overview on how to develop and bootstrap a frame if you're participating in the hackathon this weekend, how you can bootstrap a frame in less than 100 lines of code using OnchainKit. And then I put the two together and let you know how you could actually use OnchainKit to define and build transactions for frames, allowing you to perform on-chain actions within your frames and build them on Base. So with that said, so I guess in this last section, I'll just cover what hackathon prizes we have going on for this weekend, the Base team specifically. So first, we're providing a prize for best AA frame dev tool, or this is our first prize. So we're rewarding a prize of $2,000 to the best AA frame dev tool, and what this means is any project that builds a developer tool that allows people to build frames that utilize account abstraction. So this could mean anything from allowing people to build frames that utilize things like paymasters, bundlers, even smart contract wallets or embedded wallets, if you can find a way to do that or find a useful way to do that, that would count as well. We're always looking for ways to reduce the friction of on-chain development for users, and we think account abstraction is a huge way to do that. So we'd love to see that also be brought into frames. The second prize we have is a prize for $2,000 for best no-code frame tool. Basically, we want to provide ways for more people to build on-chain. So the best way to do that is to also target users that don't know how to code, or see code as a barrier to entry for building out their vision for the frame that they want to build. So if any builders this weekend want to build a no-code tool for creating and hosting frames, we think that'd be actually a very powerful and very valuable tool for developers. And then finally, our third prize is a $1,000 prize for just the most creative frame. So we want to leave this one a little open-ended. So if you guys want to create any frames around art, music, games, dynamic NFTs, it's really pretty open-ended. So we just want to encourage everyone to get creative with this one. And let's see. And then, that's pretty much it. So there's helpful resources on the right here. So we have our base.org site, which has our documentation at docs.base.org. This teaches you how to build on Base. We also have a full set of guides on there as well for specifically building frames and using OnchainKit. If you're mostly interested in using OnchainKit to build your frame, we have onchainkit.xyz, where you can find the developer documentation and API references for that. And then if you want to reach out to the Base team, interact with us on social media, we're at Base on Farcaster, and also on GitHub at base-org if you're interested in any open source contributions or contributing to open source with us. And yeah, that's pretty much it.
Awesome. Cheers. Thanks, Taylor.
Yep.
So yeah, we do have a few questions. After making the frame, how can other people use it?
Yeah, sure. So after making the frame, you can deploy it to production. So with OnchainKit, if you use OnchainKit and you fork that repo that I mentioned, you can actually set up a Versal project. And Versal has a very easy way to kind of link a Versal project to a GitHub repo. So if your code is in a GitHub repo, you can connect it to your Versal project and have it be automatically deployed to production. From there, you'll have a URL. And what will happen is that URL, if you post it in Farcaster, it'll be displayed as a frame. Or you can actually take that URL and Warpcast has an embed tool that you can find in the Farcaster frame documentation, where you can paste your frame there. If you don't want to like post it for everyone to see yet, you can post it there and test it there as well.
Okay. And could you send links to the repos that you shared or that you
Yeah, definitely.
discussed?
I'll drop those in chat.
Um, and then somebody wants to ask how they can integrate PWAs as a frame on base with OnchainKit. Example, a spreadsheet-based PWAs on base.
Sorry, can you repeat that?
Yeah, so somebody wanted to know how they can integrate PWAs as a frame on base with OnchainKit. An example they provided is a spreadsheet-based PWAs on base.
PWAs on base. Um, so I think you can. I think it's fully compatible. So OnChainKit should be fully compatible with any PWA you create. So I guess it would depend on like what you're trying to accomplish, like with the PWA on base, I guess. Um, so yeah, OnChainKit itself is pretty like library framework agnostic. It's pretty much just a JavaScript library. So it should be fully compatible with any PWA you're creating. If that answers your question, I'm not unsure.
And yeah, if Manu, if you want to take yourself off mute and ask as well, you're more than welcome to do that too. Well,
Hi,
so-
Taylor. Are you
Yeah.
able to hear me?
Yeah, I can
Am I
hear you.
audible? Okay, great. Yeah, basically, what we are trying to achieve is we basically are trying to integrate. So, as you mentioned about the developer tool, so we are trying to create a developer tool, basically a low code, no code tool for citizen developers that basically know how to use the spreadsheet and how to basically create an app and deploy it on base using OnchainKit. So, we have a structure through which they can easily create a low code, no code app on base, and we wish to deploy it as a frame using OnchainKit. So that was my basic question. I think you have answered it correctly. That if you have a URL, it is fully if you have a PWA, it is compatible with Base and it can be deployed as a frame once the URL is there on Versal. So definitely, thank you so much for
Yeah,
sharing feedback.
that's correct. Yeah.
Awesome. And then, yeah, there was another question. And for the debugger you showed, is it interchangeable to the ones Frog or Frames.js provides? Seems like they have more control and mock options for local frames.
So I will say our frame debugger is a little elementary at the moment. It's currently still under development, but it does provide like basic testing and functionality for frames debugging. So like basic interactions of like button clicks and different actions you can do. I'm not too familiar with like how fleshed out the Frog Frames.js debuggers are, and what the parity is there. But if you're doing basic frame development, you should be good. Yeah, but yeah. I'm unsure what the parity is exactly, but it is very at this current moment the debugger is pretty elementary, I would say.
Nice. Okay. And then yeah, I guess just the main thing or the other thing was if the links to the repos. I don't know if I don't think you have you shared those yet?
No, I haven't shared them. What would be the best place to drop those at?
Actually, if you want to drop them in maybe the Discord, well, you can drop them here in the Zoom chat or in the Discord channel in the base partner channel. That would work too, I think. The other option, maybe if you also want to just email them to me, and then I could do that for you as well.
So we have, I'm dropping them in the Zoom chat. So we have OnchainKit GitHub repo, and then we also have, let me just get this one. The one that's probably the most useful for hackers this weekend will be the frame in 100 lines. So this is going to be the bootstrapping repo that allows you to bootstrap a frame in less than 100 lines of code.
Nice.
Yeah.
Could we also get the one for the loader so we could like debug locally?
Yeah, sure. So the debugger itself is actually available in OnchainKit's repo. And the instructions to run that locally should be in the README itself. Let me
Okay.
just find the link.
No, I think that was, oh, sorry.
Here it is. So the debugger itself is called FrameGear, and the link for it is there in the README for the FrameGear directory.
Awesome. Cheers. Thanks. Are there any other questions or from anybody? And if not, thank you, Taylor, for the great workshop presentation. Second to last one of the day, and thank you everybody else for attending. So yeah, we've got one more left. But yeah, we will see you all in a little bit. Cheers, Taylor. Everybody have a good Friday and good
Thank you, guys.
weekend.